Hi there, it's time for Physical Sciences. My name is TK. Welcome, and this is StudyMate lesson number 19. And we're talking about chemical equilibrium. It's a continuation of what we've already started, and today we'll be talking about the equilibrium constant. Right, now, equilibrium constant is given by the concentration of the products divided by the concentrations of the reactants. Okay, now the equilibrium constant is given by the concentration of the products divided by the concentration of the reactants. A bigger Kc value indicates a chemical equilibrium which is shifted more to the right, and therefore we say that the forward reaction is favored. And contrary to that, if we've got a smaller value for Kc, that would indicate that the chemical equilibrium is shifted more to the left, thus the reverse reaction is favored. Okay, and you also need to know this very, very important aspect here, that the Kc value is dependent on the temperature, okay, around where the reaction is happening or around the reaction mixture. And for that reason, temperature at which equilibrium is reached, at which equilibrium, a state of equilibrium is reached, is always indicated. You will see that they will say this equilibrium is reached perhaps at the temperature of 500 degrees Celsius. It is because they know that temperature is one factor that affects the Kc value. Three factors affect state of equilibrium: temperature, pressure, concentration. But one of them, which is temperature, also affect the Kc value. Okay, now coming up with Kc expressions. If I've got this one here, Kc for this chemical equilibrium here will be given by the concentration of C to the power C times the concentration of D to the power D divided by the concentration of A to the power A times the concentration of B to the power B. That is how we come up with an equilibrium expression. Now let's have a look at the following to see in real terms, because the previous one is hypothetical. Let's see how we use it, or how we come up with Kc expression for real situations. Let's look at this one. Because here we've got gas, 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 all this should be part of our Kc expression. Kc for this one will be equal to concentration of ammonia, NH3, and it's balanced, so it's the power 2 there, divided by the concentration of N2 to the power 1 times the concentration of H2 to the power 3. Okay, so that is the Kc expression there. The next one, we have got a solid here. The solid cannot be part of a Kc expression. So for this one, Kc will be equal to concentration of product. Product is CO2. Okay, and there's nothing to divide with because this part here is solid, that part is solid and can't be part. So Kc here is just the concentration of CO2. Okay, now here, let's have a look at it. Kc will be concentration of product, SO4, 2 minus, okay, times the concentration of H3O plus to the power 2 divided by, this one is liquid, it cannot be part of that, so concentration of H2SO4, okay, and to the power 1. That's it, how to come up with Kc expressions. Let's talk more on this in the next section.